Namaskar. So, in yesterday's class we discussed about the maximum power transfer theorem, and we discussed few of the examples when independent sources were available in the circuit. So, now let us start the today's lecture. In this lecture we will more focus about the circuit where the dependent sources are available, and we will try to solve the circuit for maximum power transfer. So, before going to the dependent source condition, let us try to understand what we discussed in the previous class. We discussed about the maximum power transfer theorem. We said that the maximum power is transferred to a load when input resistance of the network, when it is seen into the network from the terminal where the load is connected, is equal to load. That means, if you see from inside the terminal, you will see the input resistance of the network, and that would be precisely equal to the load. So, to do this we use Thevenin equivalent, because if you see the network which may be having multiple sources and multiple elements, what we have to do, we have to convert it into the Thevenin equivalent which is there in the figure, and then we can analyze the maximum power transfer. So, now Thevenin equivalent is very useful in finding the maximum power a linear circuit can deliver to the load, and we also discussed that entire circuit is replaced by Thevenin equivalent except for the load. The overall circuit can be shown as given in the figure. Now, we also discussed that if you keep on changing the load from 0 to infinity, there would be one condition at which your power being absorbed by the load is maximum, and that is the power being given to the load by the source is maximum. So, that condition comes when RL, that is the load resistance, is equal to Thevenin resistance, and we stabilize that the power is nothing but I square RL, and we derived the maximum power transfer condition. How we derived? We used dP by dRL, that is differentiation of power P with respect to variable, that is load, and we stabilize that the derivative of P with respect to RL is 0 when RTH is equal to RL. That means, at RTH is equal to RL, the maximum power which will be transferred to the load is VTH square upon 4 RTH. Now, as we discussed in the previous class, the maximum power transfer takes place when the load resistance is equal to Thevenin resistance. This we derived when we took the derivative of power P with respect to RL, which is variable. And now, as we know that at the when the derivative dP by dRL is equal to 0, at that condition the RL value what we get, if you supply that value RL into the power P, the power might be maximum or minimum. Now, we have to find out whether the condition which we have stabilized with the help of taking the derivative dP by dRL is really a maximum or not. So, what we have to do? We have to double differentiate the power with respect to RL, and we will prove that it is less than 0. So, when it is less than 0, when the d2p by drl2 is less than 0, that means that the RL value which we have found when we took the derivative, that is RTH, would be maximum. So, how we will find out the values of various elements like VTH, RTH and RL? when the dependent source is available in the circuit. First, what you have to do is first remove the load from the circuit. Now, the circuit which is left without load, what you have to do? You have to find the Thevenin's equivalent of rest of the network. Now, when you find the Thevenin equivalent, first thing you have to do, you have to find the RTH, where you will set the independent sources equal to 0. It means that if you have an independent voltage source, you will keep it as a short circuited, and if you have independent current source, you will keep as a open circuit, and you leave all the dependent sources connected to the network. Now, you will next do what? You will excite the network with the voltage source V naught, and you can use either V naught or I naught depending upon your convenience of simplifying the circuit. You can use V naught or I naught as a 1 volt or I naught as 1 ampere, connect to the terminal where load was previously connected. Then you obtain the value of RTH, that was nothing but V naught upon I naught. So, V naught is the value which is across the terminal where you have connected either the voltage source or current source, and then divided by current supplied by the source, that is I naught. And now, after that you will find the corresponding Thevenin voltage. Finally, what you have to do? You have to set RTH is equal to RL, because as per maximum power transfer theorem, your Thevenin resistance should be equal to the load resistance, and then your maximum power transfer condition, that is maximum power transfer being supplied to the load, would be given as P max is nothing but VTH square upon RT upon 4 RTH. So, we will utilize this process to find out the maximum power being transferred to the load when dependent sources are available. So, let us take one example of maximum power transfer theorem, then we will go to the dependent sources condition. Suppose if this is the circuit and you have to find out the value of R such that the maximum power is being delivered to the load is 3 milliwatt. So, now we are not asking for load RL, we are asking for finding out the value of the unknown resistance R, so that the power maximum power being delivered to the load is 3 milliwatt. So, what we have to do? We have to first find the Thevenin equivalent. So, for Thevenin equivalent, the equivalent circuit for RTH, that is Thevenin resistance, would be, you will short circuit all the voltage sources, because there you have 3 independent voltage sources. So, you will short circuit them and you will remove the load RL, and you will see what would be the input resistance across these two terminals. So, you will get this circuit as an equivalent circuit for after short circuiting all the voltage sources, and then you need to find out the value of RTH. So, here you will see all the 3 resistances are in parallel. So, what you can say, if it is RTH is nothing but R equivalent across these two terminals, then you can write R equivalent is nothing but 1 upon R equivalent is nothing but 1 by R plus all, for all 3 we will write 1 by R plus 1 by R plus 1 by R. So, this will become 3 by R. So, therefore, the R equivalent which you will get is nothing but R by 3. Now, next task is to find out the value of Thevenin voltage. Now, let us assume that the voltage at this particular node is V naught. So, what we can write? We can use Kirchhoff current law at this particular node, and we will try to find out the value of VTH. So, what you can write at this point? For 1 volt, what would be the current? So, suppose if you are taking all in this direction, that may be I1, I2 or I3. So, 1 minus V naught by R is nothing but I1 plus I2 would be 2 minus V naught by R plus I3 is nothing but 3 minus V naught by R, and sum of that as per KCL, the sum of the all currents at this node would be equal to 0. So, what you get from here? You get the value of V naught. So, if you simplify, you will simply get the value of V naught is nothing but 2 volt. And what is V naught? V naught is nothing but Thevenin voltage. So, what you get here? You get here the value of VTH as 2 volt. So, we have got RTH, that is R by 3, VTH we got as 2 volt. So, maximum power transfer condition is P max is nothing but VTH square by 4 RTH, and the maximum power transfer given in the question is 3 milliwatt. So, what we can write from here? RTH is nothing but VTH square by 4 P max. So, you can replace RTH and P max, it will go here, P max will come here. So, this will become VTH square by 4 P max, and you know the value of VTH, that is 2 volts. So, VTH square will become 4 divided by 4 into P max is 3 milliwatt, and the whole value is equal to what? That is R by 3, which we have calculated when we found the value of RTH. So, using this equation you can simplify and you get the value of R, that is nothing but 1 kilo ohm. So, this will help you to find out the value of unknown resistance R in the circuit, which will make sure that the load which is connected to that circuit is getting the 3 milliwatt of power. So, now let us come to the another example where you will see there is one dependent voltage source available. Now, we have to find the value of resistor. Suppose if there is a load say RL connected across the terminal AB. So, you can say like this. Now, we need to find out the value of RL which will absorb maximum power from the circuit, that is the circuit which was given in the question. So, the load which will absorb maximum power from the circuit. So, what we have to do? We have to first find the value of Thevenin equivalent, that is Thevenin equivalent resistance as well as Thevenin voltage across the terminal A, B. So, what we will do first? First we will short circuit the independent voltage source, leave the dependent source as it is in the circuit, and then we connect the voltage or current source to solve the circuit to find the value of RTH. So, here what we are going to do? We are adding 1 milliampere of current source across the terminal A, B. Why 1 milliampere? Because the resistances are in kilo ohm. So, we can connect 1 milliampere so that the circuit can be simplified. So, what we have done? We have considered since the resistances are in kilo ohm, we have added current in 1 milliampere, so that voltage would remain in volts. So, now you have got this circuit. You see in this circuit there is no voltage or current source because the connected voltage source in this particular segment is short circuited. We are left with only the dependent voltage source, and then we are connecting 1 milliampere as a source external to the circuit across terminal A, B. Now, what we have to do? Let us apply the Kirchhoff current law at node A. So, this current source is supplying current to node A from this side, and let us assume that the direction of current in other two segment is as shown in the figure. So, what you can say? You can say 1 milliampere is nothing but the sum of current going outside the node. So, the value of current going outside the node, this current would be the value of node voltage. Suppose the node voltage is V A. So, the current flowing in this resistor would be V A divided by 40. Then for this current, the voltage V A minus, so what you can write, V A minus of 120 V naught, because the direction of dependent voltage source is opposite, that is minus is upper side, plus is the below. So, you can simply write V A minus of minus 120 V naught divided by 10. So, that will simply become V A plus 120 V naught divided by 10. So, when you simplify, what you get? You get 40 is equal to, so this will go here and 4 will be multiplied in this segment. So, finally, we get 5 V A plus 480 V naught. So, this is the equation which we get from this particular segment of the circuit. Now, what is next? Next, if you see the circuit, here, you will see there is no source available in this segment. So, what does it mean? The value of V naught would be 0, right. So, since V naught value is 0 and this value V naught, which is across 1 kilo ohm, is the variable which defines the value of dependent voltage source. So, what will happen in that case? Since V naught here is 0, the value of dependent voltage source, that is 120 V naught, will be 0. So, what we get finally? We get finally, if you put the value of V naught as 0 here, you will finally get 40 is equal to 5 V A. So, if you simplify, you get V A is nothing but equal to 8 volt. So, then what would be the value of Thevenin resistance? Thevenin resistance would be RTH is nothing but V A divided by 1 milliampere, and RTH will be equal to 8 kilo ohm. Now, the next task would be the finding out the value of Thevenin voltage. So, what we have to do now? You have to take the original circuit. So, you will retain the sources now. So, the voltage source which we short circuited in case of RTH will come back in the circuit again, and now we have to find out the value of the voltage which is across 1 kilo ohm, that is V naught. So, from this segment, if you see this segment, the 8 volt is supplying current to both of the resistances, that is 3 kilo ohm, 1 kilo ohm both. So, this is nothing but voltage divider circuit. So, finally, voltage V naught which is across 1 kilo ohm would be 1 upon 1 plus 3 into the value 8 volt, or you can simply write the loop equation and simplify it. So, if you write the loop equation, you will get the value of current, and then you multiply the current with 1 kilo ohm, you get the value of V naught. So, if you write the equation current I1, I1 would be nothing but 8 divided by the value of resistances, that is 8 kilo ohm, 4 kilo ohm. So, this will become I1 is nothing but 2 into 10 to the power minus 3 ampere, that is 2 milliampere. So, across 1 kilo ohm the voltage V naught would be nothing but 2 into 10 to the power minus 3 ampere into 1 kilo ohm. So, this will again will become 2 volt. So, you can use either of the technique, either voltage dividers technique, which is like you can simply find out the value of V naught, or you can write the loop equation and find out the value of V naught. So, now you got the value of V naught, which is the dependent variable for this dependent voltage source. So, next what we have to do, we have to find out the value of VTH. So, here if you find out the value of VTH, what you get? You will get again the voltage divider circuit, or alternatively you can write the loop equation, say I2. So, I2 would be nothing but the current, the voltage which is minus 120 V naught, and the value which you can find out. So, let us write the complete equation. So, what we can write? If you start from here, that is 120 V naught plus 10 10 into 10 to the power 3 into I2 plus 40 to 10 to the power 3 into I2 is equal to 0. So, I2 you will simply get from here is minus 120 V naught divided by 50 into 10 to the power minus 15 to 10 to the power 3. So, this you got from the loop. So, what would be VTH? VTH would be voltage across 40 kilo ohm. So, this will become minus 120 into V naught divided by 50 into 10 to the power 3 into 40 into 10 to the power 3. So, this 10 to the power 3 terms will cancel out, you will get finally minus 120 into V naught. So, what is the value of V naught? V naught value we just calculated is 2 volt. So, that will be into 40 divided by 50. So, if you simplify, you will get finally the value of VTH is nothing but minus 192 volt, or simply you can use the voltage divider circuit, that is 40 divided by 40 plus 50 into minus 120 V naught, and you will again get the value of VTH as minus 192 volt. So, now you have got VTH, you have got RTH. So, you will find out the value of power P. So, you simply put the value of power P as VTH square upon 4 RTH. So, that would become like minus 192 square divided by 4. RTH you got 8 kilo ohm. So, you just put value of 8 into 10 to the power 3, and when you will simplify, you will get the value of the power which is being transferred to the load is 1.152 watt, and this would be the maximum power which is being transferred to the load, which would be connected across the terminal A B. So, in this way you can find out the value of maximum power being transferred to the load when any dependent source is available. Now, next we have another circuit where the dependent source is available, I will leave this particular circuit for you to do it at your home, so that you get the better idea about how to solve the circuit when you have the dependent sources available. So, I will just give you the clue that how you will solve it. So, we have to find out the value of R L, which will draw the maximum power from rest of the circuit. So, this would be rest of the circuit. What you have to do? You have to find out the value of R T H and V T H. So, what would be the value for R T H? What you are going to do? You will simply short circuit this. So, you will get circuit like this in this case. So, this is dependent voltage source. So, you will represent it like this. So, this is 3 V x, this is 1 ohm, this is 2 ohm, and then you have 4 ohm, and you need to find out the Thevenin resistance. So, what you will do? You will apply 1 ampere current source across the terminal, and you find out the value of V naught across the terminals, and the value of R T H would be V naught divided by 1 ampere. So, just solve it, and when you will solve, you will get the value of R T H as 11.22 ohm. Similarly, for V T H, what you have to do? You have to just solve this circuit where you have 9 volt as supply, 2 ohm, and you have resistance, then you have dependent voltage source, and here you have 4 ohm resistance, which does not have any impact because the terminal is open circuited. So, here you can just try to find out the value of V T H, where these 3 V x is there, and 1 ohm is the resistance along the 3 V x dependent voltage source, and the dependent variable for the depending source, the dependent voltage source is the voltage across 2 ohm resistance. So, what you can do? You can just simply write the loop equation and simplify to get the value of V T H. So, when you will simplify, you will get the value of V T H as 7 volt. So, now you have got R T H and V T H, and you can simply find out the value of P max as V T H square divided by 4 R T H. So, you apply this particular equation and find out the value of P max. So, I will leave it for you to do it at home, so that you get the value of the Thevenin equivalents. So, with this we close our today's session. Namaskar.